Hey guys, so today we talked about binomial distributions. Uh, a binomial distribution is a specific form of discrete probability distribution that we introduced yesterday and the day before. So in order for something to be a binomial distribution, there are four specific conditions that it must meet. The first condition is that there are a fixed number of trials. This case, trials can also be substituted with experiments. So the exact number doesn't really matter as long as we are going to do the trial or experiment a specific number of times. Um, the second condition is that the success probability is the same in each trial. This means that every time we do the experiment, our probability of succeeding is the same. Essentially, what this means is that each trial is independent from each other. Which leads me to my third condition. There are only two outcomes of interest, success and failure. Now, what success is going to be defined by the question. It can be rolling a 6 on a six-sided die. It could be making a shot in soccer. It could be drawing a specific card or a specific suit in a deck of cards. It could be picking your favorite movie randomly from a playlist of movies. So there are many ways to define a success, and you'll have to look at the question to determine what that is. Number 4, the random variable x represents the number of successes in the experiment. And this will usually be a range of numbers. Normally, the lowest amount of success possible will be 0. You can't have negative successes, but in most cases, it is possible to have all have no successes in an experiment. And the maximum would normally be the number of trials in the experiment. We'll go through how to find x when we get to the examples. There are also a few variables to note in a binomial distribution. N, P, and Q will be mostly the same for our distributions that we will study in this chapter. N is the number of trials or number of experiments. This is basically how many times we're going to do something. P is the probability of success. Normally, this will be given to you, but sometimes, depending on the context, flipping coins, dice, or cards, you will have to calculate this yourself. Probability of failure is basically the opposite of a success, right? In this case, if the probability of success is 60%, then the probability of failure will be the opposite of that, right? The rest, which is 40%. And so one way to represent Q is to represent it as 1 minus P if you're doing decimals, or 100% minus P if you're doing it in percent. Both ways work. You can either represent your probability as a decimal, a percent, or a fraction. All ways are acceptable. Finally, x is a random variable representing the number of successes. So again, this will normally be a range from 0 to whatever the number of trials is. To look at this closer, we're going to do a few examples to determine whether or not something is a binomial distribution or if it's not, and also how to determine these variables. So example 1, a certain surgery has a success rate of 0.92. The doctor will perform that surgery on 10 patients. So in order to determine if it is binomial, we need to look at the 4 conditions. So the first condition, there are a fixed number of trials. In this case, there are, right? We have 10 patients, so that means that the number of trials will be 10. The probability is the same for each success in each trial. I think I changed that definition a little bit. Let me copy that. Essentially, but the definition is still the same. Each trial is independent. In this case, this is correct. A surgery does not affect another surgery, and so each surgery will be independent of each other. Number 3, there are only 2 outcomes of interest, success and failure. In this case, this is true. A success will be the surgery being successful, and a failure will be not that, right? And the random variable x represents the number of successes. This can also be true. We can have x be 0 success, we can have x be 1 success, 2 successes. And so in this case, is this a binomial experiment? It is. And so then we need to define what a success is. In this case, a success is simply a successful surgery. Surgery. And now we need to identify the variables. As we can see, n is the number of trials. In this case, we have 10 patients, so 10 trials. Probability of success is 0.92. This is given. Probability of failure would be 1 minus 0.92, which in this case is 8, 0.08. Again, these you can either write as 92% and 8%. That's fine too. Now, x is the number of possible successes, right? It is possible that out of 10 patients, all of them did not have a successful surgery. So it can be anywhere from 0 to 10, right? We can't have 11 successes with 10 trials, nor can we have negative successes. So we'll move on to example 2. And here, if you want, I'll let you pause the video and try to figure this out yourself. All right, so regardless of whether or not you pause the video, I'll go through this example. Binomial experiment. Again, we have to look at the 4 conditions. Fixed number of trials, 50 balls. That is correct. Each trial is independent. Yes, whenever you hit the ball, it doesn't affect the next time. So these are independent. There are only 2 outcomes, success and failure. In this case, yes, he either hits a home run or he doesn't. And the random variable x, correct, it's the number of home run hits this player makes. So in this case, it is indeed a binomial experiment. What is a success here? In this case, a success is the player hitting a home run. Hitting a home run is a success in this example. Identifying the variables, number of trials, 50. We have 50 balls. The probability of hitting a home run, this is also given, 0.28. Q, which is our probability of failure, would then be 1 minus 0.28, which gives us 0.72. Again, you can write these as 28% or 72%, and that would be fine. X, the number of home runs hit, can be anywhere from 0 to 50. And that would be my variables. The next example, 8 cards are drawn from a deck of cards without replacement. Let X be the number of cards drawn that are face cards. Condition 1, there are a fixed number of trials. We're drawing 8 cards. Each probability is the same for each success. This is false in this case. In this case, since we are drawing cards without replacement, the first probability before we draw a card would be 12 face cards out of 52. The next card will be either 12 out of 51 if we didn't draw a face card, or 11 out of 51 if we did draw a face card. So in this case, because the probability is changing each time we draw a card, these are dependent. So in this case, it is not a binomial experiment, not binomial, because it did not fulfill condition number 2. We can also move on and see, did it fulfill number 3? In this case, yes. A success is drawing a face card. A failure is not drawing a face card. Number 4, number of successes. In this case, number 4 is also fulfilled. So this example does fulfill 3 of the 4 conditions, but it didn't fulfill all of them. So it is not binomial. If it is not binomial, you don't have to answer these questions because it will be impossible to identify some of them. So in this case, this will be not binomial. And yeah, this is basically the introduction to binomial distribution. The key part of this is that you will be able to quickly identify if something is binomial, and then what are your values for n, p, q, and x. We will be using these values tomorrow to calculate the exact probability using a binomial distribution. So let me know if you guys have any questions, either during class or by email, and I'll see you guys tomorrow.